So I want to give a quick introduction to the book I recently published with A-Press New York, and it's called Unreal for Mobile and Standalone VR, Creating Professional VR Apps Without Coding. And so I'm going to talk a bit about the blueprint projects in the book. And actually, I was first approached by a different publisher to write about all VR platforms, but which I didn't want to do because I thought like Android-based HMDs are the most exciting area at the moment, and I thought this is quite the most interesting area to do stuff, and this is where most of the growth is expected. And so I talked to A-Press about it, and so we did this project. Next slide. So a quick note on what I do. I run a business in Singapore called Studio CG Artist. I do mostly 3D visualization and B2B VR apps. So my typical workflow is below there, and this is also reflected in the book. So I basically talk about the workflow, my pipeline, how I produce stuff, mostly for B2B VR apps. Okay. So a quick intro on who this book is for. The book is for CG artists coming from a visual effects background, so people who are not used to real-time graphics and who may be new to the PVR workflow, and media designers interested in learning real-time graphics and VR concepts, VR creators interested in optimization techniques for Android-based HMDs, and developers looking for a practical Unreal blueprint intro to standalone VR. So the book covers a lot of stuff. It's down there: ecosystem, workflow, pipeline, concepts, also stuff like photogrammetry techniques, because that has become pretty popular. And it talks about production approaches, differences between platforms, building basic components. You know, it looks at the basic building blocks like locomotion, teleportation, object interaction, basic game mechanics, graphic optimization, and also specialized stuff like AI-driven character setup and performance analytics and optimization. Okay. So the question is, why no coding? Why blueprints? So I mean, blueprints are awesome because they allow you to build and prototype faster. And they're perfect, especially for VR stuff, for narrative type experiences and B2B product exploration. And they allow you to do complete productions from start to finish. And I'm saying that because a lot of people still believe that blueprints are only for level design or only for prototyping, which is not the case, because you can do complete productions with blueprints. And there's a lot of great examples where people did everything with blueprints, 100% blueprints. One of the most famous examples is, of course, the popular VR title Robo Recall, which is like 100% blueprints. So blueprints, as you may know, is visual scripting, and that's the name for the visual scripting system inside of Unreal. Okay. So here I want to show a quick example of one of the chapters in the book. It's for a B2B product presentation, and it uses the widget interaction component and custom events. So it may be a little hard to see here, but okay. So basically, I just want to, with this example in the book, I want to show how straightforward it is to build like the typical B2B application. You know, typical B2B applications are like product exploration apps, where you have a product where you want to reveal features in the product and highlight things. And so, for example, in this example here, we have 3 blueprints. The first blueprint is the VR pawn, which is the user. The second blueprint is the floating menu with 4 buttons, and the third blueprint is the object, which is like a jet ski prototype on a stand, like in a warehouse where you want to present a product development. So, and the whole thing, the whole idea about this is to interact between the different components. And this is a great example how straightforward that can be done. For example, we start with the jet ski blueprint. The jet ski is originally a static mesh, which gets converted into a blueprint actor. And in the blueprint actor, I create 3 custom events. And these custom events set a material. Obviously, previously I would have to set up the different materials for it. And once I have that established, I can go on to the UMG widget component, widget blueprint, which is the floating menu. And here we can, it's a little hard to see, but here we can create the events for the individual buttons. And with the buttons, I have like 4 different actions here. The first one is show engine, which actually triggers a sequence animation that lifts the hood and exposes the engine. And the other 3 buttons just do a color material change. And it's very straightforward to hook this up. So the first button triggers the level sequencer player, and the other 3 reference the other blueprint by with the node get all actors of class, and by referencing that we can access the custom event inside of the blueprint. So I'm showing this example because this shows you how straightforward this process is, because usually what you usually do is establish the blueprint communication with blueprint interfaces and so forth. But in this case, I'm using the get all actors of class, which is like a shortcut, But it's also known that get all actors of class is a very, very performance-hungry node. So it's usually advised not to use it if you have a lot of stuff in your scene, like a lot of arrays and so forth, which usually in VR you don't have, because due to platform limitations, you hardly ever have a lot of stuff in there. Okay, so this is basically the core, the basics of a B2B app, and it shows you how straightforward that is. And so in this chapter, I actually go through the whole thing, like build the geometry, first blocking it out in Unreal, then blocking it out in Unreal, then taking it into Blender, refining the geometry, then going into Substance Designer to do the textures, and then actually also creating the asset in ZBrush. So basically the whole process from start to finish. And it's a pretty straightforward process. And that's why blueprints are amazing, that you can do this kind of stuff really quickly and easily. Okay. So here's the next example, and that is from chapter 7 in the book. This is a bit of a more complex project. The previous one, so in this, with this example, I want to show how to build basic gameplay, and mechanics using communication between blueprints, using variables, casting, blueprint interfaces, and event dispatchers. And this also shows the power of blueprints in Unreal, and how amazing it is to work with this blueprint system. So the idea is about this is the following. So basically, here is a sort of a mini game. This small game works like this. There's actually 2 rooms and an escape corridor. So in the first room, you have to find 2 keys to unlock the sliding door, and also an igniter to equip the bomb later. So you basically, in the first room, you have to start at A and first find the chest of drawers, which includes the red key. So you have to open the drawer, collect the red key, put it in your inventory, which is here. And then you have to find the second, the blue key, and that is hidden under a pile of boxes, as well as the igniter. So you have to pick these items up and put them in your inventory. And so once you go to the door, you can use both keys with the inventory menu, using the use button, and unlock the sliding door. And then in the second room, you have another challenge, which is you have an AI-driven character, which is a guard that's guarding the second room who's trying to attack you. So you actually have to pick up these health items to be able to survive the guard attack. And because your initial health is only 20% and the guard attack's power is 30%, so if the guard attacks you right away, you would die immediately. So basically you have to pick these items up and survive the guard attack, and then you have to make it to the exit door, equip the bomb, and then once you equip the bomb, a timer goes off that explodes the bomb, which blasts open the door and also kills the guard with a death animation. So, and this whole system, is all built with blueprints, and here's a snapshot, which is maybe a little hard to see. This snapshot is basically of one of the many blueprints. This is actually the bomb blueprint, and that shows you how I use, in this example, event dispatchers. So event dispatchers are really awesome in Unreal, because you can, you can use event dispatchers to trigger events. So in this example here, this is the bomb blueprint, and I have in the beginning here an event begin play, and after the event begin play, I establish a reference to the VR pawn, and from the VR pawn, I establish by casting a reference to the VR UMG, which is the menu, the UMG widget, and then I bind an event dispatcher event, which is the bomb explosion. And the bomb explosion is I spawn an emitter at the location of the bomb, and the emitter is basically a particle explosion, and after that I destroy the actor. So the cool thing about this is that, you may be wondering, why is it at event begin play, So the interesting thing about event dispatchers is that at event begin play, you kind of have to arm the event dispatcher, and after that, after it is initialized, it just sits there and waits for the message to get triggered. So basically, when the time has come and I'm using the igniter to equip the bomb, at that point a message is being sent out to the event dispatcher to trigger off this event. So, and the cool thing about this is that event dispatchers are great to communicate between different blueprints. And so I'm not only using this for the bomb explosion, but also to kill off the guard and trigger the death animation, but also to blast open the door, which is actually a level sequence animation. So basically, in this chapter, this chapter is a complex chapter that has a lot of stuff in it, but it shows you the power of blueprints and how to communicate between different blueprints, and it doesn't use any level blueprints, because in the previous examples that I showed, like in the very first one, I was using the level blueprint, but this one is purely blueprint communication, and it's very powerful because you can build really complex systems with it. Okay? So here's another example also from chapter 7. So here I'm talking about the AI character workflow. And the AI character workflow is interesting because I'm building everything from scratch in this book. So everything in the book is built from scratch. Here we're starting with a stand-in mesh, which is a static mesh component. I set up all the rigging, the skeleton, the animation, tweak the animation in third-party programs like Kitsu, and then I bring it into Unreal and do the blend animation. For example, here this is a blend animation blueprint where I blend between the idle animation and the attack and walk animation. And then here, on the right, because it's an AI-driven character, so I'm using the AI system in Unreal, which is amazing. It's called the behavior tree, and the behavior tree works like this: that you set up a behavior by establishing a root, a selector, and a sequence. And the sequence is you can create different tasks, and the tasks always execute from left to right. So it can be as complex as you want it to be. So you can build the most amazing complex behavior tree with all sorts of conditions. So I try to keep it simple here because all I want to do is I want the AI character, the AI system to find out where is the VR pawn, so the user. And once you find the user, I want the AI character to go there. So what it does, it does all the path finding. So no matter where I would hide, the AI would always do the path finding, which means that even around obstacles and so forth. So the way to do this is to basically create a custom task in the behavior tree, and avoid the move on to the side a little bit. So basically, so this is the task the custom task that I created for the behavior tree, and this custom task is just doing a simple thing. It's just looking for where the VR pawn is and saving the VR pawn's position into a blackboard key. So the blackboard key is a way of the AI system, the behavior tree, to communicate with variables. And that is actually what's over there, the custom task that gets then executed, and where we have the AI find the pawn and then moves the AI-driven character to go after him. And so this is just an example of how straightforward actually this whole system is. Okay, next one. So, and then here is another example of the book, which is, this is chapter 8. In the book, in this chapter, I talk about optimization techniques, optimization tools, graphics debugger. And the examples I have here is basically the blob shadows, because on Android-based HUDs, for example, dynamic lights and shadows is a big no-no. So as you may know, on Android-based mobile VR headsets, I mean, you cannot use dynamic lights and shadow because it's too performance hungry. So you have to find a replacement. And there's an old school technique called blob shadows that goes back to the late 90s, early Unreal Tournament and stuff. So that old school technique is now coming back into play when you're doing stuff for Android-based HMDs. And in the book, I'm showing two different ways of doing blob shadows. And actually, what it does, here's an example. It's actually I'm actually creating a translucent object that interacts with other scene objects, as you can see here, and then it's just parented to the moving object. So it's basically a trick to trick you into believing that it's a shadow. And this example here is just a square one. In the book, I have another one, which is a round, blurry one. So it also, you can, it's up to you what kind of complexity you want to build into it. So the other things that are kind of special about mobile and standalone VR headsets is the fact that you're not on a PC, so usually you don't have a keyboard hooked up to your standalone headset. I mean, it has become easier to use keyboards with mobile standalone headsets. It used to be really troublesome. You had to sideload some Android apps. Now it has become easier, but nevertheless, it's still a good idea to build your own custom menus for some of the standard console commands that you would always need in game to check performance. And here it's a very straightforward. You just build an UMG widget with some of the most common console commands and put it in a custom UMG widget and assign it to a controller key. And then you can, as long as you develop, you can always press a button and have it pop up and select it with your motion controller. So it's a pretty easy way to have in-game, while you're in the headset, you have all your options available and accessible. So the last thing I want to mention here is, the last thing is, like in the book, in this chapter, I talk a lot about the Unreal tools, like for example, that are there for performance optimization and analytics. For example, the session front end and the GPU profiler. And also we have, from the Oculus side, we have some great tools like the Oculus Metrics tool and so forth. But there's also some third-party tools that are great. One great tool is RenderDoc. RenderDoc is a third-party tool that allows you to really dive deeply into individual draw call events. So, for example, if you have a troublesome scene in your development, and you're having trouble with one specific frame drop, and you can't figure it out with other tools, then it's time to use RenderDocs. With RenderDoc, you can really dive deeply into individual draw call events and pull out and dissect everything, and it's amazing. I can really recommend it. It's an amazing tool to take things apart, and it's highly recommended. Okay, that's basically it. I just wanted to give you guys a quick introduction of what projects are in the book. I have 2 books I can give away if you're interested. If you're interested in Unreal development for VR and so on, HMDs. And so I only have 2 copies to give away, and to get a copy, you have to answer a question, and you have to be one of the first 2 people to answer that question. And the question is, you will find the answer to that question on the blog on my webpage. The question is, what game engine was I using 15 years ago? Okay. Okay, that's it. So if you have to go through the trouble and go to the blog and find out what game engine I was, and send me an email. The first 2 get a free copy. I've only done it. All right, thank you.
Does anybody have any questions for Cornell? Like maybe you want to write a book as well, you can ask him like how to get published. Yeah.
Any questions?
We have some
Any Unreal users?
Any Unreal users?
Not a single one?
Yeah.
I mean,
that's one.
Where? Yeah.
That's one.
Oh, okay. I mean, I can really recommend to you guys to check out Unreal. It's a much nicer experience than Unity. Seriously, you know.
I think a lot of people is things.
I used to be a Unity user, and I swear to you, it's a lot better. A much more complete package. It's more zen. You know, you don't have to worry about millions of plugins, and it's very complete. You know it's there and it works, and you don't have to worry about the thing. And just look into it. I swear.
Any questions?